believe that's the correct date. Alrighty. So we're going to talk about object-oriented programming classes again. Worth hitting more than once. So a class is the blueprint for a collection of data, variables, and of functions, which are technically called methods, that act on that data. Now that doesn't mean that every class has to have data. Doesn't mean that every class has to have functions. But in general, that's what a class is. And you use class to make objects. An object is a variable that points to an instance of that class. Right? You have a blueprint. Blueprints for an awesome house. You don't have a house, you just have a blueprint. That's your class. Then you hire a team and they go and they build your house. Now you have an instance of that blueprint. Right? You have an instance of that class. Now you have an object. House is your object. Right? So you have a 3D printer. Right? And you have a file that's going to tell the 3D printer what to do. Well, that file is just data, right? It's a blueprint. Doesn't actually have, and then you send that file to the 3D printer and it makes your little plastic whatever. Then you have an object. So an object is an instance of a class. So class equals blueprint, object equals house made from the blueprint. Silly examples, but hopefully that goes with it. So let's define some terminology. Hopefully these go along pretty closely with what the book has. Every book defines these things just a little bit different. It's just the terms that differ, not the concepts. That's why I tend to say things like functions, parentheses, methods, right? Just to remind you that, those are the same things. A function is just a method is just a function that's part of a class. We know how to write functions. Well, we can add functions to a class and then all of a sudden they are called methods. Similarly, the variables that are part of a class, they can be called members, they can be called fields, they can be called attributes. Different programming languages call them different things. We'll probably just call them data members, according to the notes that I'm giving you now. Okay, so if I was going to give a more technical definition of a class, I would not. I've already defined it. So we're going to define a few things. A class variable is a variable that is shared by all instances of the class. Now we haven't seen that. We didn't do that on Thursday. I'll show you what that means. That's like if you have a blueprint and you have an architect, right? And the architect is named, John Quincy. Every house you make is made by the same architect, right? It's the same for all the houses you build. So it's shared by all instances of the class. Every object has the same value for a class variable. Kind of an abstract concept, and it's okay if you don't totally get it, but I bet you can. Okay, and so then there's a data member, a variable, sometimes known as a member variable, sometimes known as an instance variable. This is the term that's most commonly used as far as I know. I believe the book calls them data members. I'll have to look it up again. Anyways, what it is it's a variable, can I type? Or a data element, piece of data, whatever, associated, I cannot type today, contained by an object, associated with an object. Right, every house you build has got a door, every house you build has got a window, and every house that you build has got a garage. Those are all data members of your house object. So House class, class variable. Architect. The same for all houses built from this blueprint. Remember, every time I say blueprint, I mean class. That's just a simile, just a metaphor. Alrighty. And then a instance variable, also known as a data member. I'm having trouble tabbing it over. Instance variable, also known as a data member, could be things like the number of bathrooms, right? The color of the paint, right? The square footage of the house. The address of the house, right? How much the house costs, right? You could come up with a whole bunch of information about, a specific house. That's about enough, though, right? So each one of these could differ on a house-by-house basis. Somebody adds a couple of bathrooms onto the back of their house, whatever. They got more bathrooms. Somebody paints their house red, okay. The other house was yellow. They differed. If you added an extension to your house, you have a different square footage. And each house has a different address on the street. That kind of thing. So that's the difference between an instance variable and a class variable. And honestly, almost everything we do is going to be an instance variable, right? Because it's going to differ on a class, on an object-by-object basis, right? This circle has this radius. This square has this height and width, right? That kind of thing. Because the idea of a variable that applies to all of the objects built from that class, it's kind of, when you need to do that. I'll demonstrate an example of it, and then I'm probably not going to use one again. We'll see. Maybe there'll be another reason to use them. Okay, so what is a method? It's a function that is part of a class. What is the init? 2 underscores around each side. Method. It's got a fancy name in some textbooks called a constructor. It's the method, the function, that is called when an object is created. Right? You make a new turtle, the turtle's constructor, the turtle's init method is called. All right, so an object, also known as an instance, is an individual example, thing. I guess I'm going to remove the word instance here, but just know that the terms object and instance are actually interchangeable. So it's an individual instance, or how about I swap those two terms? Right, we're going to say that an instance is an object built from a class, just like your house, just like a turtle. We made a new turtle. We called it Leo, right? Leo is the instance of the turtle class, so that we can tell Leo to go forward and turn right and draw circles and things like that. All right, and then we're going to throw a really fancy term in. Just because computer scientists can never leave well enough alone, we have to have fancy terms for everything. Instantiation is the creation of an instance, the creation of an object. When you make a new turtle, that's called instantiation. I'm going to instantiate a turtle. I'm going to instantiate a turtle. There, now you have a new turtle. You can tell them to draw lines and stuff like that. When you instantiate the turtle, it calls the init method for the turtle class. All right. So we're going to come up with a class. It's not going to have much data built in because this is just going to be a sample. I'm going to come up with, excuse me, a mouse class. We're doing lab rat experiments and we need to track our lab rats. So what I would do is I would use the word class to indicate I'm defining a class. You don't use DEF, you use a special word. If you use DEF, it means you're defining a function. It has that very specific method. Okay, class mouse. And then we need an init method for it. When we create a mouse, we want to be able to pass in its name, but we need to do the self parameter first. We will always see the self parameter for every method we create. And if you're a Java or C++ programmer, instead think the word this whenever you see the word self. They mean the same thing. It's just that guy who programmed Python wanted to call it self rather than this. All right, and when we create a mouse, we're going to give it a name. We're going to give it an age. And we're going to give it a weight, right? Weight in grams or something. Age in days, weight in grams, something like that. Alrighty. And then we're going to write a function called grow. Every time we call grow, the weight is going to increase by 1, and the age is going to increase by 1. Now that's kind of silly. There ought to really be a growth rate variable that you could set. And you know what? I'm going to make this simpler for now, and I'm just going to do that, and we're going to specify all the variables without passing them in as parameters. So when we create a mouse, we want to set its name. We want to set its age. It's 0 days old. We want to set its weight. It's 1 gram. Mouse babies are small. I don't know. And it's G rate for growth rate. And this mouse grows by 10% every day. You know what, I think I'm going to flip over and I'm going to actually create this in idle. So if you weren't typing along, feel free to type along now. We'll be giving more examples. Okay, so what lecture are we on? QRSTU. All right. So class mouse, DEF underscore underscore init underscore underscore parentheses self. You'll always have self whenever you define a method. When we create the mouse, we're going to create a variable, an instance variable, data, called name, age, self.age, self.weight, and I hate G rate, but I don't want to type out the whole word growth rate. It just takes too long. How about G underscore rate? That looks a little bit better. And now we're going to write a couple of more methods. We're going to write a method that prints information about the mouse, and we're going to write a method that adds 1 to the age and increases its weight, right? So every day, mouse gets a day older, it gets a little bit bigger. So how about one called grow, and again it has to have the self parameter, and every time it grows, its age increases by 1. Self.age plus equals 1, and its weight increases. Now, I'm not going to get into the details of how you calculate an increase in weight based on a % growth rate. You can just accept this on faith because there's like 4 different ways to write it, you know. Self.weight times equals parentheses 1 plus self.g underscore rate. Let me bring this over. And we'll test it out to make sure it works. Really, that's enough for now. We don't need to go too crazy, right? This will demonstrate it. So every instance variable we define is going to be defined within the init. If we had any class variables, like I mentioned, like the signature, the architect for the blueprint, you define it outside, above the init class. I'm not going to make a class member yet. Alrighty. So let's make a mouse. M1 is equal to mouse. Now let's print the thing's age and weight. So print mouse age equals %d or %f, wouldn't matter. Weight equals %.2f. End quote, space, %, and then I need an open parentheses and I need 2 closing parentheses, and inside that pair of parentheses I need to pass in the pieces of data that I want to print out, which is the mouse's age and the mouse's weight. So inside those 2 parentheses it's going to say m1.age, comma, m1.weight. Now I'm going to wind up copying and pasting that. And eventually I'm going to get tired of that, and I'm going to create a method that does the same thing, that prints the information out for that mouse. All right, let's call grow on it. m1.grow, and now I'm just going to copy and paste that print line so I can see how big it is after it grew. So with a 10% growth rate, since it started at 1, after 1 day old, it ought to weigh 1.1. And then, after that, I can't think through, 1.2, 1.5, or who knows. All right, so this is lecture U. Let's go ahead. Save it. Take the space out of my file name. Don't need that. Alrighty. It's very possible I have syntax errors. I guess we'll find out. I could remove some blank spaces to try to make things a little bit more concise. There. Well, it's going to work. It didn't work. Oh, yes, it did. Right? Its age increased and its weight increased by 10%. Well, I'm going to call grow twice and then see how old it got. So after that, I'm going to do m1.grow a second time, just because I want to see, make sure it's working. It ought to say that it's 2 days old. All right, and yeah, I think that's working. All right, I think what we ought to do now is go ahead and create a display method for it, or a print method for the mouse, so that we can call it and it prints that information out. So here we go. Define display, parentheses self, in parentheses colon. So we're just going to print out a couple of things. Print, parentheses, quote, mouse name equals, end quote. Wait, don't want to do that. Mouse name space equals, comma, quote, comma, self.name, parentheses. Now I'm going to copy and paste that because I want to print out its age and its weight and its growth rate. And so I'm doing this just so that I can copy and paste and make a few changes. Right, so I want 4 print statements. The second print's going to print age, the third one's going to print weight, and the fourth one's going to print G rate. So mouse name equals blah, 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 mouse age equals self dot age, mouse weight equals self dot weight, and mouse g underscore rate equals self dot g underscore rate. Now I'm going to delete these print statements down here, or at least comment them out, because I'm going to be calling the display method of the mouse. I'm going to do m1.display. I'm just going to comment that out. m1.display. And then here I'm going to delete this second print statement and call m1.display again. And then I'll pause and make sure that everybody's got it going on. All right, so the mouse name is default. That's pretty boring. His age is 0. He grew 2 days. Maybe we ought to make the grow method print something just so that we can know that it's growing, right? And then after 2 days, that's his age, and that's his weight. Yeah, that's kind of silly. We ought to do like %.2f to limit the grams. Meh. Yeah, let's go ahead and do that. We're going to make a couple of changes. We're here where it says self.age, let's say days, so that we know that it means days and not hours. So self.age, comma, quote, days, end quote. And the weight, I want it to be formatted to 2 decimal places. So I'm going to do this. Quote %.2f. Uh-oh. Stop that. Undo all that. So after the comma, I'm doing quote %.2f, end quote, percent self.weight. That formats this piece of data to have 2 decimal places. And honestly, I can then get rid of these extra double quotes, right? I don't need quote, comma, space, quote. That's kind of a pain. This would work, but I can just delete all that. Make it look a little bit better, more like what we've been using. I think the output will look cleaner now. Oh, and let's put the word grams after this %.2f, just so that we know what we're weighing, right? You know, our mouse doesn't weigh in pounds or tons. So the units, grams, right there. Mouse weight equals %.2f grams. All right, so the mouse name is default. We still ought to fix that. Mouse age is 0. His weight is 1. His growth rate is 0.1. And then after 2 days of growing, he's 2 days old and he weighs 1.21 grams. All right, I'm almost liking it. What am I not liking? I'm not liking the fact that his name is default. That's real lame. So what we're going to do is we're going to add some parameters to the constructor. And in the meantime, I'm going to stop and make sure that everybody got this working. All right, I'm going to demonstrate an error in this just to show you a problem and how I would think about fixing it. I'm not going to tell you what the error was, though. I went past it too quickly. I'm going to run. All right, and it blows up. Mouse has no attribute name. Well, okay, that's in line 16. That's in line 23. Let's go take a look. All right, so 16 is right there. Well, yeah, that's line 16, all right. Why doesn't it know what self.name is? I called it self.name here. I'm not seeing a problem. So just to see what's going on, I'm going to comment that out as well. Don't make these changes, by the way, because your code's hopefully working. And now mouse object has no attribute age. Now that's where I throw a fit and I go, I know it has an age. Now the problem here is that I have misspelled the init method's name. Right. I accidentally only put one underscore there after the two. So if you start getting those errors, attribute not defined, or whatever it was, let's run it again just so that I can remember the name. Right. Object has no attribute. If it says that, and it keeps saying that no matter which attribute you try to access, it's probably because your init method is spelled wrong. It needs to be 2 underscores, the word init, and then 2 more underscores. All right. Now that's a real easy mistake to make. Alrighty. So, I don't like the mouse being called default. I could change his name right here, right before we create him. m1.name equals Mickey. So we create him. This default value is assigned to self.name, but then we're going to reset it to something else, right? And heck, maybe Mickey came out a little bit larger. m1.weight, he's 10 grams. He's a big baby. And so these are all before we display and we grow them. These are the 2 changes we just made to set 2 attributes. Alrighty. And there we see, oh, I commented out the name. I need to go and uncomment that line out. All right. And so Mickey's 0 days old. He weighs 10 grams. And then after 2 days, he weighs 12.1 grams. So that's working. What I would like to be able to do is to pass in his name. Here's what I want to be able to do. I don't want to have to pass in. I don't want to have to do those 2 things. I mean, it's great and all that, but it'd be cooler, it'd be faster for me if I could do this. Mickey, comma, 10, right? Indicating his name and how heavy he is. Right, we measured him as soon as he was born. We know that information. So now I don't need to do those 2 things. I'm going to comment them out. All right, it's not going to work yet. I have to go and modify the constructor. I have to go and modify the init class to have 2 more parameters, one for name and one for age. So I'm going to come up here, and here where it says self, I'm going to do name and then age. And so the name is no longer going to be default. Wait, not age. That was supposed to be weight. Sorry. So name, comma, weight. His name is not default anymore. He's whatever the programmer passes in. And his weight is no longer automatically 1. It's whatever gets passed in. All right, and so here's Mickey. He weighed 10 grams. And we were able to set those values without doing this business. Now, there's nothing wrong with doing this, you know, changing his name down there. But it's kind of nice to be able to specify that stuff when we create them. So you can modify your init method to accept whatever parameters you want to set whatever data variables you want. Now we could add 2 more parameters. We could add one for the age and we could add one for the rate, so that if we wanted to, you know, this mouse is 5 days old and he has a growth rate of 0.2. Right. We could do that. We could add 2 more parameters in order to support that. I'm not going to bother. I'm going to show another syntax for changing his name other than that. And you won't, the textbook's not going to show this. I'm pretty dang sure about that. But there's nothing wrong with you seeing it. After he grows 1 time, or after he grows twice, we decide we want to call him something else. Let me get the syntax, make sure I don't get it wrong. All right. So here we're going to change his name. Set attr, and then our object name is m1, right? Because that's the variable that's containing this object. And what attribute do we want to set? We're going to set, quote, name, end quote, to, he's no longer Mickey, he's Ricky. Or we decide that he's a she, and so we call her Minnie. So then the second time we display, we'll find out that the mouse has a new name. Now, would you normally do that? No, this is the nicer syntax, right? I'd rather do m1.name equals Mickey than set attr m1 comma, right? That's the cool way to do it. That's the nice way to do it. There's a technical reason, though, that we might want to do it like this, and I'll show you. Alrighty, so Mickey, 0 days old. After the mouse grows, we print the mouse out again. It's now Minnie. Right, so we were successfully able to change that attribute. Attribute being data variable. Maybe I better go and update my notes to that effect. So an instance variable is also known as an attribute. Sorry for the multiple names. Can't help it. Different computer scientists came up with different names for the same thing, and they never took a vote and, you know, fixed it all. Okay. The reason I'm putting attribute here is because the set attr, right, stands for set attribute. Okay, here's the reason you might want to use set attribute. You can create new attributes on the fly. What if, you know, we have a couple of different colored mice, right? We have brown mice and we have white mice. And so we decide that we're going to say m1 dot color is equal to white. This is a white mouse. That's going to blow up. That's not going to work. It's going to crash on this line. The reason why is because there is no color attribute. Why? Because it was never defined up here. So, since there's no color attribute, we can't set it to white. Oh ho ho. Make a liar out of me. We can create those attributes on the fly. We can just create whatever we want. M1 dot, you know, whatever is equal to, you know, whatever. That's not a syntax error. Okay. You have no need to ever use that. I'm going to delete it. Right. So you can add attributes to the mouse after it's done. But then you're not guaranteed that every mouse has that attribute, right? Because I just added this one, white. But if I created a new mouse, M2 is equal to mouse, you know, Ralph, who's 5 grams. And then I try to print out M2.color, it's not going to work. Print M2.color. Not going to work because only this mouse has a color attribute set. All right, so you can check to see if a mouse has an attribute before you try to not a mouse. You can check to see if an object has an attribute before you try to access it to prevent that kind of error. Now this is going a little bit beyond what the book shows, but that's okay. I'm going to mention it and then it's not going to show up on an exam, but I want you to have the idea. And this is the kind of stuff that Python lets you do that languages like C++ and Java do not. Those languages do not let you customize your object on the fly by creating new variables attached to it, which is what we're doing here. Okay, so what we need to do is before we try to print the mouse's color, we need to see if it's there. If has attr, parentheses, M2, comma, quote, color, end quote, end parentheses, right? If M2 has the attribute, colon, then print that color out. Let's make the print statement a little bit more interesting. M2 dot name, comma, quote, is, end quote, comma, m2.color. Right, so it'll just say, you know, Ralph is white or brown if it exists. And take these statements here and copy them and paste them up here underneath the M1 display. But change those M2s to M1s after we do it. So I'm going to grab those two statements. I'm going to paste them there. And I'm going to change if has attribute. We're checking to see if mouse M1 has a color attribute. And it will, right? Because we did that. Oh, and by the way, this is stupid. I'm going to delete that line. Don't need that ASDF, whatever. Okay. And so if the M1 mouse has a color attribute, then we're going to print out the mouse's name and the color. So we are going to see that Minnie is a white mouse. However, we never set a color for Ralph Mouse. Don't know if y'all ever read the book The Mouse and the Motorcycle when you were a kid. That was his name, I believe. Alrighty. So Mickey is white, but it did not print anything for Ralph. If we set Ralph's color, we can do that, right? M2 dot color equals, quote, he's this very strange mouse. He's green. Now it will print that Ralph is green. All right. So we can add attributes. We can add new variables to an object on the fly. Just want you to have that idea and know that it's not possible in other languages, and it is possible in this. And if you're going to do that, then you have to take some care when you try to access those variables. Because if you access an attribute that doesn't exist, it'll blow up like we saw. It'll have the red text. What is the safe thing to do? Well, if I really want to be able to access color for every mouse, I need to just go up and define color way up here, right? Self.color equals white or something like that. You know, then I wouldn't have to worry. Then I wouldn't have to use this syntax about checking to make sure it has that attribute. I'm going to pause it, make sure that we're all doing okay. Alrighty. Now that we have two mice, we're going to put them in a cage of mice. Put them in a list, just so that we can print out all the mice in our list. So, I think I'm going to print some kind of message here. Here is our cage, right? Now let's create a list called cage. Now remember, variable names aren't important. I could call this capital L, I could call it anything I want, but it's an empty list, and now I'm going to add two mice to it. Cage.append, parentheses M1, cage.append, parentheses M2. Now I'm going to display those mice. So for value in cage, or for every mouse in cage, I'm going to go with V. For V in cage, colon, print, or excuse me, what did we call our method that displays everything? Oh yeah, dot display. V.display. So just print out all of the mice in our current list. So here's our cage, and it's got our two mice in it. Ralph is never aged, so Ralph is 0 days old. That's appropriate. Why don't we grow them both 10 times? Right, we're doing some weird experiment. We're going to age them 10 days, and then we're going to print them out again. I really would like to add a print statement to our grow method just so that we can see that it has been called. You know, normally you don't want to clutter your methods up with stuff like that, but I think it'd be pretty cool if up here we added a print statement. Print self.name, comma, quote, is growing. Right, so to print Mickey is growing, or Ralph is growing, or whatever. And like I said, would you normally do that? Would you normally make all of your methods in your class print stuff out? No, because that's going to make the output noisier, right? but just for our own fun, you know, we're writing this to entertain ourselves. So I added that to our grow method just so that I can watch every time we call m1.grow, we can see that it happened. Alrighty, so let's age them both 10 times. So for x in range 10, right, this is the shortest possible way of writing a loop that goes, you know, 10 times. And as a result, x is going to equal the values 0 through 9, because this is always 1 greater, right? Okay. And then for v in, no, let's not get complicated. m1.grow, m2.grow, and then let's print our mice out again. Print after 10 days, end quote, comma. And then just yank this for statement again, right? Save ourselves a little bit of typing. All right. So we see what, whoops, sorry, let me bring this back. We see what's happening here. 10 times in a row, Mickey grew and Ralph grew, and Mickey grew and Ralph grew. And after all that, then Mickey wound up being a lot heavier. Why? Because he started off heavy. He started off twice as heavy as Ralph, and he's also grown 12 days rather than 10. And if you grow a percentage, but you start off with more, you wind up with a lot more at the end, right? You know, if you have a 10%, you know, interest on your savings account, and you start with $100, somebody else starts off with 1,000, they're going to have a lot more money at the end of it than you are. Okay, so this is almost as far as I want to take this example. The only thing I'm going to do different, the only thing I want to change now is give an example of a class variable rather than an instance variable. And the class variable is going to just display how many mice we have created. Anybody need eyeballs? Okay, so to add a class variable, we come up here and we define it above the init method, and we don't put self. Because we're not in a method, we don't have a self to add it to. So we're just going to say num underscore mice equals 0. And every time we call init, we're going to increase that variable, and we're going to set an instance member equal to it. So num underscore mice, because we created one, right? We called the init function, plus equals 1, and then self dot mouse underscore num equals num underscore mice. So what's this doing? We start off with 0 mice, but the first time we construct a mouse, the first time we build one, we increase the number of mice, and then we set a piece of data equal to that number. So one of the mice is going to say, I am mouse number 1. The second one's going to say mouse number 2. And if we created them, then we'd have a third mouse and a fourth mouse and a fifth mouse. To see that information, though, we're going to modify display. So how about this? Mouse number, end quote, comma, self dot mouse underscore num, comma, quote. Right? Because when we print the mouse out, now we're curious about his number as well as his name. So Mickey's always going to be mouse number 1, and Ralph is always going to be mouse number 2, because that's the order in which we create them. I'm going to hit enter right here just to get all the information on the screen. You don't need to do that because you see more on your screen than I do, just because my font's large. Oh, and it blew up. Num mice reference before assignment. Well, if this example doesn't work well, I'm just going to delete everything. Let me check my notes. Silly me. You see where it says num mouse? You see where the rest of these have self? Here's what we got to do. To access a class variable, you have to prefix it with the name of the class itself. So here where I have num mouse and here where I have num mouse, I'm going to have to prefix it with mouse dot. So like this. Whoopsie. This line needs to be mouse dot num mice. This mouse dot here means that this variable is part of this class. It makes me wonder why I don't have to do mouse dot, num underscore mice right there. I wonder if that'd be a syntax error if I did. And I need to do the same thing for this num underscore mice too, right? I just need to tell it where this variable came from. So mouse dot num mice there too. That should take care of my syntax errors. So I changed these two lines and I put mouse dot in front of num underscore mice. Alrighty, so after all that growing, mouse number 1 is Mickey, mouse number 2 is Ralph, and if we created some more mice, mouse number 3 would be somebody, mouse number 4 would be somebody, mouse number 5 would be somebody, and so on. So this is an example of a class member. It exists kind of outside of all the objects, right? It's not a self member, it's not an instance variable. It's a class member because we're keeping track of how many mice we have created. That information is not part of any particular instance. We record that value right there. But this way we can keep track. How many mouse objects have we created? If we create 1,000 different mice, then by the time we're done, we printed them out, the num underscore mice would be equal to 1,000. And then if we displayed all of them, we'd see mouse number 1, mouse number 2, mouse number 3. So this one applies to every object. It exists outside of all the individual objects. It's a class member. And the way you access it, if we wanted to print out the number of mice, print number of mice in created equals, end quote, comma, mouse dot num underscore. Let me make sure I get the right one. Yep, num underscore mice. So back down here. Print number of mice created equals, end quote, comma, mouse with a capital M, comma, num underscore mice. And that'll say 2 because we've created 2 mice. Want to create some more mice? M3 is equal to mouse, and his name is Joe, and he weighs 1 gram. I'm just going to create some more mice, M4 is also equal to Joe, M5 is equal to Joe, just because I want to see it say 5 mice have been created. All right, number of mice created, 5, because that information exists outside of all the individual objects. It's not like each mouse is going to have a different count of all the mice that were created, right? The number of people on the planet is 7 billion. It's not like there's 6 billion for me and there's 7 billion for you and 2 billion for you, right? For everybody, the number of people on the planet is 7 billion. Lastly, last change I want to make to this. What if I don't like having to give names and weights? I may like it, but what if I don't always want to? What if I want to be able to do this? If I'm in a hurry, I don't want to give the mouse a weight, an age, and I don't want to give it a weight, and so I'm hoping to get some kind of default values. That's going to be a syntax error. But we're going to modify it so that it has default values for those parameters. Here's what it's yelling at me about. Missing 2 required positional arguments, name and weight. So when we called the mouse init function, it didn't have all the arguments it needed. If we scroll back up to init, we'll see that it had one parameter called name and one called weight. We're going to go give some default values to those so that we don't have to provide them. So what's his default name going to be? I don't know. Name is equal to, what's Tom and Jerry? Jerry. And the weight is equal to, every mouse by default is 2 grams. Now we don't have to specify that information. And if we don't, then his name's going to be Jerry and he's going to weigh 2. And if we do, then he's a custom mouse, right? He doesn't just have that information. So these are default values for the parameters. That way we don't have to specify them, but we can. Right here we have been specifying, but here we're not. Let's toss all of these mice into the cage and then print them out one more time. So our cage is still called cage. That's our list. So cage.append M3. And then I'm just going to copy and paste that to make it M4, M5, and M6. I'm throwing all the mice in a cage. Silly terminology. I'm just appending them to the list. So we're having a population explosion in our cage here. And let's print a message. After new mice added, end quote, comma. Let's just write that for loop again. For v in cage, for every value in the cage list, v.display. And so we're going to see several mice named Joe. If I don't want that, I could change one, to Mary, and one to, if you remember the Hamtaro cartoon. Hamsters are not mice, but so be it. Alrighty. Ooh, well, what do you know? I made a typo there. What did I do wrong there?
You didn't put that second quote.
Yep, missing the second quote. And I just closed my program. Brilliant. Alrighty. So, there. No, that's not a quote. There we go. Alrighty. So, somewhere up here it's going to say, after new mice added. And this is kind of like noisy, right? It's got almost too much information, right? It's hard to make sense out of what I'm seeing. So the last thing we do before we close it up and we submit it is I'm going to change the printing. And here's what I'm going to do. Up here, where I print this information out, after or before the final parentheses, I'm going to do this, comma, end equals, quote, semicolon, something like that, space, end quote. And then just copy that and paste that before every closed parentheses except for the last one. And I've botched it. I'm going to undo those because they really need to include the comma in my copying and pasting. So I'm going to copy everything, comma, space, end equals, quote, semicolon, space. You'll see why I did that. So here I need a comma, end equals, etc. Here I need a comma, end equals, etc. Whoops, and see, now I have 2 commas. And that looks all good. When I run it, though, I'm going to see the word mouse repeated too often. And so I'm going to wind up deleting the word mouse from these 3 print statements just to make it look prettier. You'll see what I mean. All right. Right, do I really need it to say mouse number 5, 4 name is equal to Mary, mouse age is equal to, right? Do I really want to do that? No, I don't need that word mouse over and over and over. So, there. Now it's still not going to look great. It's scrolling off the edge of my page and, wrapping around and stuff like that. But yeah, that looks pretty good. If we took the growth rate variable off, then maybe it'd look better. If we change the word number to a number sign to shorten it, it'd look a little bit better. I'm going to do that. I'm going to change number to a number sign. I'm being picky. I'm going to take this growth rate out entirely. And if I do that, then I just need to add a final print. Otherwise, they're going to wind up all being on the same line, right? Because this end prevented it from going to the end of the line. So I'm going to do that. Hopefully, they'll all fit. Now, you didn't need to do that. Your screen's larger than mine. You have more text. There we go. I like it. That's my output. That's my final output. Mouse number one's name is Mickey. Ralph, Joe, Mary, Hampton Row. And we could go to the trouble of adding tabs and stuff like that to make it look all pretty and stuff, but I think this is quite enough. Alrighty, so I hope the idea of object-oriented programming is a little bit clearer now. What makes this object-oriented? Because we have a single variable that has a whole bunch of information in it. Right? We created a variable called M1, but it's not a number, it's not a string, right, whatever, it's a whole conglomerate of information. It's got a mouse number, it's got a mouse name, it's got an age, it's got a weight, and it's got a growth rate, right? So this one variable has all that information in it. And that makes it very easy to manipulate lots of information, right? If we were going to track 6 mice without having these objects, it'd be a real pain, right? You'd have to create like 6 different variables for everything, right? Mouse 1 name equals whatever, mouse 2 name equals mouse 3 name. And then it was, suppose if you wanted 1,000 mice, are you going to do mouse 999.name equals a mouse 999.age and so on. So we have created an object that has data that's contained in it, right? It's got all this data that's contained in it, and it's got some functions attached to it. We can grow those mice and we can display them. If we wanted to do other things with them, inoculate them against, the flu or something like that, we could add more methods. All right, that's about enough. Any questions? Yes, sir. Okay. All righty. Anybody need the stuff kept on the screen anymore? All right, guys, I'm going to upload this as notes, so if you have syntax errors, you can go and access the notes.